Let's take a look at a couple applications involving polynomial functions. So this first graph is just real data from 2005 to 2011 showing average January gasoline prices at the pump. So first thing, I want to make sure that we can read graphs and interpret them. So if I'm looking at this and the question is, what years was the average price per gallon in January increasing? Well, that means it's going up as we read from left to right. So from 2005 to 6, we see that this trend is upward. Then it takes a slight dip. So 2005, 2006 is the first time. Then a sharp increase between 2007 and 8. And then we had some decrease. And then finally, we have here 2009, 2010, it's increasing. We're still increasing from 2010 to 2011, it's just not quite as quickly. So my answers then would be between 2005 and 6, 2007 and 8, and then from 2009 all the way straight through 2011. There's no reason to stop at 2010 just because the rate changes a little bit. All right, next question. Could we estimate the maximum average January price per gallon and say what year it occurred? Well, we have a couple peaks here. If I'm looking at this, 2008 looks pretty high, but I'm looking over here, this one looks just ever so slightly higher. I would say in 2011, we would have our maximum price. And if I want to look over here, it's just over the halfway mark between $3 and $3.25. So I would say that's probably about $3.13, $3.14 per gallon. Again, that was in the year 2011 where I saw the highest spot. All right, so next question. Let's see if I can hide the answer here for a minute. If I would want to think about a polynomial model, I would want to think about the degree that might be appropriate. And to help me with that, I want to think about the number of turning points, because you recall that the maximum number of turning points is always one less than the degree of the polynomial. So turning point means I'm changing from increasing to decreasing. So we would have this one here in 2006 where it changed. Again, in 2007, it changed. In 2008, it changed. And in 2009, it changed. In 2010, it changes the rate, but it's still increasing. So that one doesn't count as a turning point. So again, I have 1, 2, 3, 4 actual turning points. So if there are 4 turning points, that means I could be talking about at least a degree 5 polynomial to model this. Last question. For this model, would I expect the leading coefficient to be positive or negative, and why? Well, remember, positive or negative tells me what the right side does. This trend is upward. Still, it's not upward real fast, it's slowing, but it's still upward. So I'm going to say that I would have a positive leading coefficient. Okay, so we would use a positive because the right side is up. Take a look at another one. This one is auto accidents. So they've given me this function, it's a quadratic function, and it models the number of accidents per 50 million miles driven as a function of X, which is the driver's age, okay? And we're only looking at 16 to 74-year-olds because you're not supposed to be driving before you're 16, and a lot of times after 74, people are not driving, or not as many people. All right, so the first question, what is f of 50? Well, we just said X stands for the age, so obviously we're talking about a 50-year-old. What does F tell me? It tells me the number of auto accidents. So if I'm looking here and I would put in 50 into this equation, I would get 450. Okay, you can kind of guesstimate it on the graph here, but that would be pretty hard. Let's just plug it into my calculator. F of 50 would be 450, so that means 50-year-olds have about 450 accidents per 50 million miles driven. Okay, so it sounds like a lot, but then you're like, wait a minute, that's per million miles. So that's not really that much. All right, let me again try to hide my other answers here. And let's look at the next question. For what value of X does the graph reach its lowest point, and what is the significance of that? What does that mean? Well, here I can easily tell that it's right here is the low spot, right? It looks like at 45, it's turning. If I wanted to verify that, remember back in chapter 3, we looked at how do you find the vertex of a polynomial or a quadratic? You take the opposite of b divided by 2a, we would get 45. Okay, so we're talking about 45 is where it reaches the lowest spot. So what does 45 stand for? The age. And what is the graph representing? The number of accidents. So it's telling me that 45-year-olds have the fewest number of accidents per 50 million miles driven. Okay, so they have the lowest rate of accidents. That's why their insurance is usually a little cheaper. All right, next question here. What's the minimum value? Well, if I plug 45 into my function up here, I would get 392.5. Again, the answer for that I'm getting is telling me the number of accidents. So that's telling me that 45-year-olds have roughly 392 accidents per every 50 million miles. That's the fewest of any category.